Okay, our first panel discussion is concerning transportation and mobile sources. And the moderator will be Bob Sawyer, who is the class of 1935 Emeritus Professor of Energy and Professor of the Graduate School. He has a long career in and around all kinds of energy topics. At one point, he was the chair of the California Air Resources Board. And so even though he did his undergraduate work at Stanford, let's give him a good welcome anyway.
Thank you very much for the introduction. Go Bears. I can't resist making some observations about Severin's comments about innovation. Having been at Berkeley and having worked for Jerry Brown during the first Jerry Brown administration and being involved in the tailpipe emission standards, California's tailpipe emission standards, I think this is a very clear case where command and control regulation drove innovation. So that can happen. But I think what we're seeing now with the automobile industry is that innovation is driving technology in the automobile industry. The autonomous vehicle is an obvious example of the next generation or the generation after the next generation of what's happening in the automobile. So I guess I do buy into Severin's statement that it's all innovation, however it comes about. Well, I'm delighted to be here. Thank you for the organizers for inviting me. We have a distinguished panel to discuss the issues of California's energy future related to transportation. On my left here is Dr. Sonia Ye. She is a research scientist at University of California, Davis at the Institute for Transportation Studies. She's worked in a number of areas spanning technology and policy. I'm most familiar with the work she's been doing on the low carbon fuel standard. Next we have Brad Edgar, who is a graduate of the University of California, Berkeley from my department a few years ago. He was also a center on the varsity football team. He doesn't look as beefed up as he was then. But he has been an innovator, started several engineering technology companies, and I suspect he may tell us a little bit about his latest venture as the CEO of 44 Energy Technologies. He had to explain to me what the 44 is all about. I'm getting dense in my old age. And lastly, we have a lawyer who will sum everything up for us. Vera Pardee, who is the senior attorney at the Center for Biological Diversity in San Francisco. And she is now focusing on climate change issues, and we look forward to her comments as well. The format is that each of our speakers will take about 10 minutes to send their message. We will exchange some information amongst us and then take questions from the audience. Sonia. Oh, wait a second, I have more myself. Let me tell you why this is so important. Our panelists. Where does California energy go? What are the end uses? You can see that transportation is the big one there. About 40% of California energy goes to move us around and move our goods around, mostly just moving people around in cars. The big consumer of energy are personal vehicles. In California, almost 3/4 of the transportation energy goes into that sector, then trucks. So this means road vehicles. This doesn't mean that the other sectors aren't important, and they will become more important in the future because cars and trucks are going to get more efficient, and we're going to depend more on rail transportation, for example. So now, Sonia.
Thank you. Thanks, Bob, for the very nice introduction, and thanks for inviting me here. So I'm going to give a very brief overview about where we think where transportation sector will go in the future in California. What are the range of possibilities without going into too much detail, and hopefully my next two speakers will give you a little bit more details, and we'll probably talk a lot about the challenges, cost, economics, technology during the Q&A session as well. So Severin talked a little bit about why this is so important to think about energy use from the transportation sector, as well as all the other sustainability issues, including air quality, water quality, greenhouse gas emissions associated with energy use in the transportation sector, addressing the challenging climate change, economic security. Notice that instead of saying energy security, I use the term economic security because energy security is usually often confused terms. And one reason that we care a lot about energy security is the economic impact. So the way we define energy security is look at the economic impact associated with energy security. So I tend to prefer to use the term economic security. Then air pollution is definitely a very important issue. Ultimately, the economic growth in society depends on the functional and ultimately sustainable transportation system. That's why it's so important. We need to think very, very far ahead about how do we develop a sustainable transportation future. So today's transportation system, very simple. We have a few oil sources, oil from different sources. Some are cleaner, some are lower carbon, some are more energy intensive than higher carbon, particularly oil sands from Canada. We also have a little bit of mix of biofuel in our transportation mix, from corn mostly, a little bit of soybean. So we have 10% in volume of biofuel mixed in our California transportation fuel system. Refineries, and then all these fuels go into the transport sector that include all modes of transportation, not just cars, vehicles, trucks, rail, shipping, aviation, and so on. In the future, there's a brighter future where we can rely on a vast range of primary energy sources from wind, solar, different types of liquid fuels and biofuels, and so on and so forth. And the conversion technology, there's also a very wide range of conversion technologies that will be needed to convert this primary energy into final energy that we can put into a range of different vehicle technologies, cars, different types of trucks, aviation system, and so on and so forth. But it's quite challenging to move from here to here. As you heard from Severin's talk, a lot of innovations are needed to go from this picture to this picture. Why transportation is unique? It's unique in many ways. One, the R&D in transportation kind of dwarf in size compared to all the exciting innovation that's going on in the electric sector, for example. There are a lot of market conditions and barriers that make policies, especially market-based policy, that are especially challenging to make any impact in the transport sector. Coordination, you can't just push, for example, fuel industry to innovate. They need vehicles to come with it. So there's network challenges. All the different pieces need to work together to move a transition to a sustainable future. The monopoly power of the oil industry and lack of competition, and so on and so forth. And ultimately, I think it's very important to pointing out that unlike all the other sectors, electric, residential, industrial, commercial, if you look at the trend, all the energy intensity, whether you measure it on energy per unit of GDP output or energy per person, all those sectors are decarbonizing for various reasons. Transportation sector is the only sector that are increasing its carbon intensity over time. So that, for us, is one of the biggest challenges. There are a wide range of policies that are needed and are implemented in California to address the transportation challenge, including, and in our department, we like to call it the four-leg stool, that we need to address vehicle efficiency. We need to address the carbon intensity of the fuels that we'll put into vehicles and other modes of transportation. We need more advanced vehicle technology, electric vehicles, fuel cell vehicles that are more superior in many ways. The fuel can be lower carbon. Vehicles are more efficient, and so on and so forth. And last one, we need better VMT management. We need to reduce our travel while at the same time be able to improve our economic efficiency, grow our economy. that require a lot of policies that come together, including land use policy, policy that encourage public transportation, the policy that encourage we to improve our productivity while reduce our travel demand. And so Severin mentioned about low carbon fuel standard. Low carbon fuel standard is one of many fuel policies that we're implementing in California that would take a baby step that hopefully will help us to reduce our gasoline and diesel consumption and increase the proportion of alternative low carbon fuels in our fuel mix. And so our projection there are 3 bars that compare what's the fuel use, alternative fuel use in the state in 2007, and business as usual to 2020, and what the low carbon fuel standard can do to slightly reduce some of the gasoline and diesel by displacing them with low carbon fuels that come from a range of sources. When we look into 2050, this graph shows that in order to meet our AB 32 2050 goal, which is to reduce 80% reduction, greenhouse gas reduction from all sectors, we know transportation need to contribute the majority of the emission reduction, because by that time, by 2020, 2030, electric sector will need to be almost completely decarbonized. So a majority of the carbon emission reduction need to come from transport sector through efficiency improvement and through decarbonization of the fuels. So when we look at, if we look at a business as usual scenario, and on the left-hand side, BAU, we will continue to increase our gasoline consumption, diesel consumption in all modes of transportation. All of them almost all come from fossil energy sources. We can achieve a lower carbon scenario, but we need to introduce a lot of new fuels, a lot of new technologies. We think that aviation and rail system will be the hardest sector to decarbonize. Therefore, some of the bio-based fuels come from good sources can play a role in reducing carbon emissions in that sector. For the light-duty sector, we'll probably need to rely on electric vehicles and hydrogen fuel cell vehicles over the very long term, but we will still use some liquid fuels. And so, kind of to conclude, I want to point out different fuel and vehicle pathways and point out some of the really big challenges we need to address before we can make a meaningful, positive transition to these low carbon possibilities. And so, for example, here I list 3 different types of fuels: hydrogen, electricity, and a biofuel that can all go into vehicles. They all face different challenges. The green color shows where challenges are smaller. Red color shows that where challenges are quite significant in those areas. So we look at different fuels and look at the challenges in, for example, in resource collection. Is there enough resource? Can we bring the resource where the conversions take place? How much does it cost? Is it easy to implement? How easy is it to transport resource from the for example, from the fuel all the way to refineries, for example, or to different efficient conversion facilities, and how easy to transport fuels from conversion facility to your vehicles and the refueling stations, and do we need to build up a lot of refueling stations, or you can charge it at home? And so different fuels actually all face different challenges. Some are higher in some areas, some are lower in other areas. Ultimately, when we look at these fuels, their challenges not only exist in terms of the resource availability, the cost, the technology readiness, and how long does it take to make the transition. And again, almost all the fuels face one challenge in one area versus the other. And what we need to do is to look at this challenge, think about solutions in terms of the technology, in terms of policy, in terms of how do we stimulate innovation, how do we put all the pieces together to create a market for demand and a market for supply. And I think that's where we need to go in the future. Thank you.
Hi, my name is Brad Edgar. First, I want to thank Chuck and Beth Travers for inviting me to the conference and supporting the conference, and they've become personal friends of mine. I met Chuck actually through the Cal football team, so there's a nice connection there. And I also want to thank Professor Sawyer. He was my undergraduate professor and taught a class on air pollution, and that really sort of caught my interest in the whole subject and air pollution related to combustion. And one of the things that mechanical engineers do is build engines, and then of course we study the fuels and the air quality impacts and all that. So it's been a interesting ride, but all sort of because of a connection with Berkeley. And one of the things I'm really proud of being a graduate of Berkeley, and I think there might be a lot of students here, is the mission of the university is to educate students for the betterment of themselves, their state, and the world. And that's exactly what we've been talking about this morning. How do we make California a cleaner place, and to the extent that we do that, how do we make the world a better place? So with that, I got a couple of slides about cars and trucks and things like that. I guess I'm a serial innovator. I think that is really part of being a Californian. It's not the question of why should you start a company, but why not? A couple of guys with some Mac Air books can start a company in a few days, and I've done it a few times, and I did another one just recently. I decided to call this one 44, kind of a stealth name. Some people think it's a cafe or a nightclub, kind of trendy, but 44 is a very important number in this whole field, everything we're going to talk about today, for two reasons. One, it is the heating value of hydrocarbon fuels, whether it's gasoline, diesel, propane. They all have roughly the same heating value of 44 megajoules per kilogram. And one of the things I've learned, if you're trying to translate across all these units between electricity and various fuels, if you can remember 44, you can make these conversions on the back of an envelope. The second one is 44 is the molecular weight of CO2. And CO2 is the currency that we're trading today and that we're working to drive down. And we talk about it in tons. Well, if you want to take that mass of CO2 and move it back to fuel, you need to know that 1 mole of CO2 weighs 44 grams. So we formed a company with the sort of fuzzy mission to be a consulting technology development group, really focused on the responsible use of hydrocarbons in a CO2 concerned world. I didn't say constrained, but concerned world. There's pressure, severe pressure to reduce CO2, and a good need to. At the same time, we have an abundance of fossil fuels. We're going to be burning them for a while. How do we do that in the most responsible way? So I want to start with just a quick slideshow here on some photos. Does anyone know what that is in that picture, what those are of, those squares? Containers, they're port containers. There's an artist in Seattle named Chris Jordan who's known as the artist of the enoughness movement. And Jerry Brown coined the term enoughness to say we all have enough. Enoughness is a way to kind of keep consumption down. So he thought they looked really nice, all these colors in this mosaic. And then a friend of his said, you're also taking a picture of consumption. So he built a kind of a collage here and said, well, what if I expand this out to more of a patchwork? The first slide was about 50 containers. Here's 850. Blow it out again, you have 4,000 shipping containers. And one more time, you have 38,000 shipping containers. Well, that 38,000 is the number of containers that go through American ports every 12 hours. And 25% of those come through our ports here in California, and 5% of those come through our port over here in Oakland. 5% of this number come through every 12 hours. So a lot of our economy is driven on movement of goods, and that relates to trucks and emissions, et cetera. But I just want to kind of position it there because when we talk about energy, the numbers are huge. It's hard to get a scope. I've heard that mentally we have a hard time grasping a number much above 10,000 just in the way our brains develop. So we need other ways to kind of make analogies, and graphically, Chris has done a very nice job. So anyway, that should get you set for thinking about some big numbers. Here's some other big numbers, just some California numbers. Population in California after the last census, 38 million. A little more, about 12% of the United States population. We have 31 million cars and about 500,000 trucks and buses. That's almost 1 car per person. Now, my kids don't drive, and I'd say 20% of the population doesn't drive, so we probably on average, have a car per person. That's a lot. But that's also easy to remember. If you remember the population, you remember the cars. Less trucks and buses. A number I needed to learn in starting 44 was what's the ratio of gasoline to diesel fuel consumption. Those 31 million cars, even though they don't consume as much fuel per vehicle, they consume about 15 billion gallons of gasoline a year. There's about 3 billion gallons of diesel fuel consumed a year, so 5 to 1. So that sort of puts it in perspective. And when we talk about where do we go for reductions, well, you can go for the fewer trucks and buses, but you're going to get less, there's less fuel consumed there. Another good number, there's a book that came out a few years ago, and this number is probably still pretty accurate. 86 million barrels of oil consumed a day. 86 million barrels consumed a day. California, just to meet these fuel consumption numbers, consumes 1.6 million barrels of oil today. So California makes up less than 0.5% of the world's population, yet we consume almost 2% of the world's oil. And then the best way to deal with big numbers is divide it by people, so how much, and it brings it home. So if you divide that by the population in California, that's about 2.1 gallons of oil per person per day. Well, that's a number you can work with, because then you can say, well, how much do I consume? Is that right? Do I want to consume less or more? It puts it in perspective. Next question, we talk about innovation and drivers, but the question I have is who really cares about fuel economy? And I think we say we do, but I'm not sure we really do. But here's an example. A truck, a heavy-duty truck, maybe a newer one that you would see FedEx or Safeway driving, costs maybe $150,000. At 75,000 miles per year, that's sort of on the upper end, but not outrageously so. Some trucks run 150,000 miles a year. 5 miles a gallon, $5 a gallon. That's $75,000 a year in fuel. So every 2 years, that truck consumes a value of fuel that's equal to its cost. It's a huge amount of throughput in that truck. Now, on the passenger car side, reasonable car today, new, costs $25,000. You run the same numbers at 12,000 miles a year, 25 miles a gallon. Gasoline is cheaper than diesel. You get to $2,000 a year. It takes 13 years to consume the amount of fuel equal to the cost of the car. So the car buyers are a little less sensitive to fuel costs, I think, than truckers, and that's why truckers complain more about fuel costs. But the gasoline cars are the ones that consume the bulk of the fuel in the United States. So what's the response? You got to take regulatory action. The EPA has set up CAFE standards. These are average fuel economy standards. The average fuel economy a couple years ago was 20 miles per gallon. And this is pretty amazing. This is innovative. 55 miles per gallon on average in 12 years from now. That's a lot of progress. In addition, California is pushing zero emission vehicles again, and they want 1.5 million vehicles on the road, which is a big number. 1.5 million, there's only about 15,000 on the road now. So we've got a long way to go. But even when that gets done, it's going to be less than 5%. EPA is not leaving it to the truck owner operators to demand fuel economy. They're forcing it on them, so we're going to start seeing fuel economy standards for engine vehicles starting next year. One interesting thing, the unintended consequence, if we start getting better fuel economy and buy less fuel, we're going to generate less tax revenue, and our roads are going to be less well served. So there's probably going to be some talk about adjusting that. I think we probably should, because the roads still get the same wear and tear. I'm going to just go through this slide, and then I'll close. But there are a lot of options out there, and I think that's the solution. Lots of options competing for the same goal, which is market share. Do not give up on gasoline. It's getting more efficient. It's the incumbent technology. It's ethanol compatible. You can plug in low carbon fuels. And the efficiencies of gasoline engines are starting to approach diesels, even though diesel efficiencies are increasing. Diesel will probably be the engine of choice for the truck driving community. Not as much penetration in the passenger car market, but high thermal efficiency. Diesels are much, much cleaner today. They're on par with gasoline vehicles, so there's not an emissions disparity anymore. They're also renewable fuel compatible. Natural gas, there's a lot of talk about natural gas because it's very low cost relative to gasoline or diesel. But the real challenge today is the infrastructure, and there aren't that many natural gas offerings on the market. And then finally, the plug-in electric. The great appeal is zero tailpipe emissions and a bridge to a utility infrastructure that generates electricity with very low carbon consumption or carbon release. But we still have to work on cost, charging infrastructure, the electricity price. Jamie Fine will talk later, but if you can understand the utility rates, I'd like to learn. It's very confusing to understand what we really pay for electricity, and so it's really hard to make that consumer choice. And then, of course, how we produce the electricity is critical, but it's a pathway. So I've got more details on these, but I'm running out of time. So I'm just going to end with a couple of predictions and comments. Because of fuel economy and other choices, I think gasoline consumption, it's dropped in the last few years. It may continue to decline. It's not going to grow as much as other fuel consumption because it's going to be offset by the increases in fuel economy. And so gasoline may stay cheaper than diesel for a long time. I'll say it again, gasoline engine at 55 miles per gallon on average. We could be seeing 70 mile per gallon gasoline powered cars, probably with some hybrid technology in them. Very efficient and very clean. Natural gas is going to gain share mainly in the trucking market. As long as the price stays low, folks will go after that. Plug-in electric vehicles will continue to grow, both through consumer appeal and through mandate, combination of the two. But the utility rate structure needs to be easier to understand, and the whole process needs to be easier to understand. What I'm a big fan of is all these solutions are in the mix. Competition is going to bring out the best. The folks in Detroit working on gasoline engines are not going to give that up without a very hard fight. And that's a good fight because at the end of the day, everything gets better. And then I'll leave it with, if you're personally concerned, there are some simpler strategies, maybe along the lines of enoughness. Drive slower. That's a tip from Chuck Travers. Or smoother, quit accelerating and braking. Walk and bike more, and then consume less stuff, because remember, all that stuff comes in on all those shipping containers. And I think that's it. Thank you.
Thank you, Brad. Vera?
Can you help me with finding my...
Try.
Yeah. Hello, thank you so much for having me. Thank you to the family for organizing this conference. I'm a lawyer with the Center for Biological Diversity and have been asked to speak actually instead of my colleague Cassie Siegel, who is busy and sends her regrets. I have been in the environmental field for just 5 years. I used to be just a general commercial litigator for 16 years and then went into the innovation space, being a general counsel for a biotech and then for a medical device company. Retired and figured out that I ought to do something better with my time and try to give back a little bit. To begin with, I would like to give a plug to command and control, somewhat like Bob did. And I listened to Severin's presentation and was just a bit depressed by it. He points out, of course, all of the issues and problems that we have with anything but the technology fix. But to me, that doesn't mean that we should give up. To the contrary, I think it's an all-of-the-above approach. I am of German heritage, and thus maybe the command and control approach comes to me a bit easier than the libertarian response that is sometimes prevalent in the United States. I still believe that regulations and laws that are smartly designed and correctly implemented are the necessary, absolutely necessary ingredient to get us going. I also would like, before I start a little bit more in the details, talk a bit about this leakage argument. The argument that we really can't do anything because whatever we will do will just result in manufacturing or any source of greenhouse gas production going from our geographic vicinity elsewhere. Hence, why even try? And Severin himself brought out a number of arguments that would defeat that. I would like to say that I see that argument all the time, and I really think we need to rethink it. Severin said it's not a good idea for California, or it's not correct. Severin said California is probably not going to be very efficient in doing its cap and trade initiative because of leakage. You can take that same argument and put it in any context. You can do that based on where you are in your own home. You can do it based on the cities. You can obviously do it based on a state in California, but you can also do that in the international arena, and that is precisely what's happening with aircraft. Aircraft, and I'll speak to that in a minute if I have the time, there has been a tremendous amount of effort trying to get aircraft greenhouse gas emissions corralled. And the fact is, most people don't understand that aircraft greenhouse gases are rising probably faster than many other transportation greenhouse gas emission increases. But the aircraft industry has been incredibly effective in the last, I would say, 2 years, particularly in stymieing every effort to try to get regulations on greenhouse gases imposed anywhere. And the leakage problem and the leakage argument is being used on every level as a defeatist sort of argument. And you can say, well, bright-eyed optimism meets gritty reality, and you ought not be quite as optimistic. But I would say to you that only a steadfast repetition of the facts of the game, plus the very intelligent use of regulations, will get us past where we are right now. After all, the Berlin Wall fell. And as a former German, I found that a fact that exceeded my potential to even grasp it. The point is, change is possible, and I just wanted to rebut that a little bit. For California, I've been active working with the Clean Air Act. As a lawyer, that is a tool that I can use to try to reduce greenhouse gas emissions, thereby increase energy efficiency, thereby begin to help the planet overcome this problem. California has a very significant role to play in the vehicle arena from a legal perspective. The Clean Air Act, of course, is a national piece of legislation passed in the 1970s that has been very cost-effective and has been able to reduce traditional pollutants at a cost where the cost is exceeded by the benefits exceed the costs 30 to 40 times. So the Clean Air Act is terrific. Section 202 under the Clean Air Act requires EPA to set standards for vehicles. There were petitions filed in the late 1990s trying to get EPA to do just that. And EPA was very slow to respond. Then it finally responded during the Bush administration and denied the petition. California then was an absolute, you probably know this, but just for those who don't, an absolute catalyst in getting greenhouse gas emissions control to be implemented, because also the national legal structure allows California to request a waiver from having to comply with national emission standards. That's because California's air was so bad, and it was so clearly traceable to vehicles. So California had the right to say, we would like to increase our standards, and you cannot deny us this waiver unless you find that our request is unreasonable and not based on the facts. Given that we had the highest emissions and the dirtiest air, it was going to be very difficult in a court battle to withstand the argument that, yes, California ought to be regulating vehicles more strongly. What that set up was the incentive for the industry to begin to play ball, because the industry didn't want to have to deal with two standards, one applicable in California and one applicable everywhere else. And California played the hand perfectly, and I understand that Bob was, incredibly instrumental, and while I only know this from a historical background, he was part of this entire deal, and I'd love him to talk about that more if we have time, because he actually knows, and I'm just reciting. But the point that I'm trying to make is that because the law was in effect, and because some smart lawyers used it well, there was then the requirement to increase fuel efficiency. I also would like to touch very briefly on the first. I'm sorry, can you hear me? Okay, I don't know whether to avoid the light or, so I'm standing still now, here I am. I want to touch briefly on the first piece of, the first case in the federal arena that helped us get to regulating greenhouse gases for vehicles. And that was a case called Center for Biological Diversity versus NHTSA. And we were just the first named plaintiff, and so I exploit that shamelessly. But in fact, we were joined by a number of states and by a number of other organizations. We attacked the CAFE ruling. I wasn't there, this is all my wonderful colleagues and others in the room. We attacked jointly the CAFE standards as insufficient, legally insufficient. So I keep thinking about the intersection between policy and law. It's wonderful to set policy. It is necessary to think about it, but the law gives us some tools. And obviously there are many setbacks, but at least we keep trying. So we attacked the CAFE standards as insufficient because they failed to take into account greenhouse gases at all. They also failed to measure in any way or give any sort of amount of cost that was going to be caused by driving and emitting greenhouse gases. We achieved a victory in the Ninth Circuit in which the court said, no, you can't do that. The law requires you to do a cost-benefit analysis, and if that is the case, you certainly cannot ascribe a value of 0 to something that clearly has a cost. And that was a very helpful decision, and it prompted the further development of the standards. How am I doing on time?
What time to wrap up?
Wrap up, oh my goodness. So very quickly, we have fuel efficiency standards now through 2025. The number of the 55 miles per gallon is actually not the number. That is arrived by counting credits, flexibilities, counting air conditioning reductions that really aren't connected to fuel efficiency.
Do you have slides that you want to use?
Yeah, go ahead. Very quickly, this is a slide that puts us into the international perspective here. What is California, not California, but what is the United States doing in connection with fuel efficiency, and how do we really compare and in setting standards, okay? You can see that the EU is ahead by far. Japan is ahead. Even China is on par with what we're doing. And then the numbers are not necessarily exactly what you think they should be, because it's not 55 miles per gallon that we are asked to achieve. It's less than that. I completely agree that we will meet this number, actually, even though regulatorily it should have been set much higher, in my opinion. Could have been set much higher, because the law is technology forcing. The law actually demands that the agency sets the standards higher than can be achieved with present technology, and that has not necessarily been done. But in any event, I share the optimism because we have these numbers now, and somebody is incentivized to reach them. Very briefly on aircraft, the international negotiations at ICAO of beginning to come up with a greenhouse gas standard for aircraft are failing. That's no news, because that's been the case for 16 years. But it's not changing. The European Union was brave and set forth a cap-and-trade system that was, it covers all of Europe, and then began to pull in the airlines on an international basis. They were immediately attacked by, mostly, American Airlines. In the High Court of Europe in Brussels, we and a number of others intervened, and the High Court actually upheld Europe's right to put a cap-and-trade system in place for aircraft. That didn't slow their industry down. They then went to Congress and lobbied very hard, created what, I'm sorry, should I stop talking? I should stop talking. All right, I'll take questions later. I'm sorry, I can keep going forever. Thank you.
Thank you very much, Vera. I think that one thing that Vera reaffirmed is that every engineer needs a good lawyer. When I was in Washington arguing the California's waiver for the greenhouse gas standards for the Pavley rule, the lawyer for the Air Resources Board is the Attorney General. And Jerry Brown chose to be my attorney on site at that time. So one of those rare cases where a university professor had the now governor of California as his personal attorney. We will move into panel format and get rapidly into questions from the audience, I think. But I had one point of clarification that I'd like to get from Sonia, who said that the energy intensity of the transportation system is going in the wrong direction. Mm-hmm. I don't think that's true for automobiles, that the efficiency is moving faster than the VMT is going in the other direction.
Right, so my comment is mostly applied to the whole transportation sector. And looking at more broadly, globally, when I make that comment. Because there are a few reasons that transportation's intensity will continue to go up. One is because even though you have efficiency improvement over time, but you also have the, let me try to think about how to explain this. Globally, we know transportation, there are two major trends that are going on. One is transportation actually moving to faster and faster modes. So we're doing a lot of mode shifting from personal vehicles to air travel, for example. That's one example of why energy intensity will go up over time. And that also happened in the freight sector. We have more and more shorter distance delivery. So for example, you order things from internet, we have shorter and shorter delivery distance. So all these things happen in different sector, different modes of the transportation will increase transportation energy intensity over time. And in China, for example, people are buying bigger and bigger cars. And so energy intensity from developing countries are also expected to go up quite significantly over time.
Thank you very much. Brad, so how do you see, if the goal is to get an 80% reduction in greenhouse gases from the transportation sector in California by 2050, is the heavy goods movement going to be a part of that? And or is that not going to be a part?
Well, I think it's going to be a part. If you look at the 5-to-1 gallons of gasoline to diesel, which was kind of a shock to me, I would have thought that you'd need to go after more of the heavy duty. My guess is the lion's share will be in the light duty with the fuel economy standards and renewable fuels. On the heavy duty, we'll see how far standards get pushed. There is a lot of room to move, but I think you should really focus on the light duty to get the reductions.
And I have one question for Vera about the aircraft. That's one of my great interests is the aircraft industry. It seems to me that the airframe industry is a duopoly now. Is that the problem that's preventing technology from moving in faster, or is it the airlines themselves that are not interested in more efficient airplanes?
I'm no economist for sure, and wouldn't know exactly what a duopoly will do. I try to work with regulations. It's not understandable to me why the airline industry fight so hard to prevent regulations, because you're right, they ought to be incentivized by reducing the price of the main factor that drives their prices up. What is happening is that the airlines tell us we are entirely incentivized. Hence, please leave us alone. We can voluntarily and will voluntarily obtain all of the results that you would like. In fact, ICCT, which is a terrific organization and knows by far more than I ever will, has debunked that claim. And for the last 10 years, actually, airline efficiency has not increased. So what are you going to do? There is law, there is advocacy, there is policy. And we actually did bring a lawsuit against EPA, in which we claim and actually prevailed on the fact that EPA is required to set, under Section 231 of the Clean Air Act, standards for greenhouse gas emissions for airplanes. And we achieved this victory I think it was last year. Then unfortunately we failed to make further progress because the next question was, when does EPA have to do this? And then the law begins to be much more fuzzy because it is a reasonable time. We had argued that since our petition trying to force EPA to do this was filed in 2007, and that 5 years might be an unreasonable response to not regulating, beginning to put in regulations. We did not prevail in that argument. The judge found that it had yet to be unreasonable, that delay. However, time will pass and we will go back and we will see if we can force this issue.
Yes, any comments from the panel members about the other panel members' statements? Or?
Well, I guess I just want to add, we're seeing the same trend for increasing energy intensity in air travel as well, because people do a lot more short distance air travels, and most of the energy consumed during takeoff and landing. So, we drive less, we fly more, and that also increases our overall energy intensity in personal travel as well.
So the one thing I haven't heard is high-speed rail. Does anybody have a strong feeling about that for California? I do.
Let's hear yours.
Please.
Well, I think most of the people in this room have either been to China or to Japan or to Europe and have been on high-speed rail and know what it's about. I think it's an embarrassment that the United States has no high-speed rail. I see California, we're about the size of Japan in terms of how we're spread out. Our population is not Japan's, but it's headed there. We're very similar to France in size and population. If these countries have had high-speed rail for decades, and there's no reason why we can't invest them. It's not a huge investment, actually, if you look at what we put in the freeway system or the rolling stock that goes on our highways. And I'm just appalled that some of the local newspapers, especially the Chronicle, come out so strongly against it. I don't know what they're thinking. Okay, let's move to the audience. Ralph. If you'd identify yourself, because this group doesn't know each other, I don't think, very well.
Raphael Friedman. I actually graduated from the Energy and Resources group. When I arrived, Bob was the chair. So we go back away. What I heard a lot here was technology. I didn't hear a lot about the humans that use it. There's some really nice trends, and I'd like you to comment about those. Working from home, using these little things to communicate instead of doing it in person. How much can we get out of that, and how can we foster that type of behavior? Taking the fast train instead of flying, these type of things, I think can get us a lot more than just relying on the technologies that you're talking about, or waiting for, unfortunately, the courts to weigh in our favor. Can you comment?
I'd like to comment. I think, a good recession, you shouldn't waste a good recession. And I think one of the things that we got out of our recession, one, fuel usage has dropped significantly, and people are trying to figure out why. But I think a lot of it is it forced everyone to take hold of all the technology that had been around, and we don't need to drive into the office. We can work from home. Maybe that's part of why employment is coming back more slowly, because you don't need as much administrative help because you can actually do it yourself. But I think the mobile commuting, working from home or remotely is a huge impact. And then the thing I'm very interested in is using the phone. You can use it as a navigation device. But there's a term called smart driving, where the phone not only can route you in and out of traffic, but it can score your driving performance. And I think that's what we really need. We need someone to tell us when we're doing things the right way and the wrong way. We don't have enough feedback. So all that, I think, is tremendously important in the near term.
You're going to have smart cities. If you're looking for parking, you will reserve that parking spot. Okay. And those things use microgrids, nano sensors, 15 watts for an entire city, so you can find a parking spot.
Right. And you know, the end game here is that you don't need to drive your car, and that will yield a lot of benefits.
So I probably just...
Let's go to the audience to make sure we don't cut them out.
Sounds good.
And Jamie?
Hi, Jamie Fine with the Environmental Defense Fund. I also graduated from ERG. Bob, I hear you. It's an embarrassment we don't have high-speed rail. When you look at other attributes of Californians, there are other things to be embarrassed about. Such as our per capita energy use, such as the amount of miles we tend to drive. High-speed rail might help with some of those things, might not help with other things. Playing the role of economist, I guess I have to remind us all that we can't buy everything we want to buy. I don't really have a strong opinion about high-speed rail, but I think that's the concern that, for example, taking monies from AB 32 revenues, the cap-and-trade program to control global warming pollution, and investing that in high-speed rail might not be the best bang for our buck in terms of emissions controls. So I guess I would ask, before we all jump on the high-speed rail train, what else might we be investing those monies in to address other big sources of embarrassment in this state?
Fair enough. Yes.
Hello, I have a question for you.
Yes, sir.
You mentioned twice about the resistance of U.S. airlines to participate in the program and incorporating their emissions into the system. By any standards, the emission trading system in Europe has been a colossal failure. Colossal failure. We have done studies for European countries. In all our simulations, we're predicting the prices will go up to 10, 15, 20, 30 euro per ton. The market has imploded. 2-3 months ago, the prices were 3-4 euro. As of last week, it was about 5 euro. The efficacy of that system really is not there. As a result, the system has not worked, and the pollution levels in Europe have increased. We don't have an emission trading system here. If you look at the numbers for 2012, they stay leveled or even they decreased. So do you care to comment on that?
Yes, I would. I would indeed. I'm fully cognizant of and agree with your observations that the cap-and-trade system in Europe is broken and that it is a shame of tremendous proportions. I'm not an economist, and I wouldn't dare to begin to go into Jamie's territory of cap-and-trade. I still and nonetheless support Europe's effort because it is at present the only international effort, in fact the only effort to get airplanes even to begin to think about regulations of greenhouse gases. So yes, it is more than imperfect, but it is all we have, except for our lawsuit. And our lawsuit actually tries to do what happened with cars, because California was a catalyst for finally setting greenhouse gas standards for cars. A national, United States national EPA-led standard for airlines can equally be such a catalyst for the international arena. So I know only two things to do other than advocacy, and I think, quoting Severin, make a big stink, I think he said that. Other than that, those are the only two things I know of. I know the Clean Air Act, and I know Europe's system. So I support them both.
Thank you, Vern.
Hi, I'm Kristen from Silvatex, a very early stage biofuel startup located in San Francisco. So a lot of the manufacturers of engines and after treatments devices such as oxidation catalysts and particulate filters have, worked very hard to meet the emissions and efficiency standards that have been, and regulations that have been put in place. But in order to verify that they actually meet those standards, they have to be certified. And that certification is generally limited to ultra-low sulfur diesel, which makes it very challenging for new fuels to get into play. So are there any comments about how people can work through that?
Yeah, I have some experience. Biofuels can be classified as a subset of ultra-low sulfur fuel. The ultra-low sulfur fuel doesn't mean it's petroleum fuel. It's just a designation based on the chemical composition and things like sulfur levels and so forth. So there are procedures to do that. There's also specific biofuels specifications by ASTM that can be done, laboratory testing and so forth. So there is a pathway through that, and I know some companies have made it through, so it's achievable. Expensive.
Well, that's my point. I think the ASTM specifications that you're referring to are generally limited to hydrocarbons that meet ASTM D975 or biodiesel, the blend stock, or for the B20. So I guess I'm referring to other fuels that are a little bit different. And because those processes for developing those ASTM standards, which are required, can take like 10, in the case of biodiesel, it's taken over 10 years. And as you mentioned, yeah, all the testing that's required is at least a couple $100,000 a pop. And like right now there's there's an advisory 379 in place with CARB, which is that to even test any fuel in a vehicle that has a DPF or an oxidation catalyst on it, it has to be warrantied. And those warranties, of course, generally are only with maybe up to B5 or ULSD. So I'm not, I'm not trying to argue. I'm just saying that I know that there are processes in place, but those are very, very limiting. And so I'm just, I guess, pointing out that some of those standards and regulations that have been put in place to really try to, do the greater good for the environment have also really, really narrowed down those who can enter the playing field and try to make progress.
Point well taken. I agree. You had a question, Sonia.
No, I was just going to comment earlier about question on behavior, and I think and that relates back to some of the comment. I don't think that technology is the only solution. I think technology solution can only get us so far. So for example, improvement in technology efficiency can also reduce the cost of travel, therefore create a rebound effect, therefore people travel more. And many people say public transit is a low carbon option, we should put more buses on the road, for example, but when you put a lot of buses on the road, they're empty trips, you create emissions. So there are technology solutions, but there are also behavior response that can upset a lot of the potential benefits. So I think everything needs to be looked in the context of the overall picture and be mindful about some potential unintended consequences.
Well, thank you very much, and please join me in thanking our panelists, Sonia, Brad, and Vera.